Okay, so this is step 3, CFOP, final step of my 4x4 tutorial. And before we get started on this tutorial, you should know two things: OLL parity and PLL parity. 4x4 has a parity that 3x3 doesn't have, and so OLL parity would be. So this would be my top, and this is my front. R wide U2 X R wide U2 R wide U2 R wide prime U2 L wide U2 R wide prime U2 R wide U2 R wide prime U2 R wide prime. And what that does is it takes these two and switches them over. So like if I did it again, green would be right here and red will be right here. And then the second one is PLO parity, and you would do that by U wide 2 little r2 U2 little r2 U2 little r2 U wide 2. And what that does is it takes these two and moves them to the back, and then these two go in the front. So as you see, green and red are no longer here, they're over here. So those are the two that you need to know for now, and then we'll come across them later, again in the tutorial later. So for now, it is like a 3x3. Matter of fact, let me grab one moment. Let me grab a. Hang on a second. So this right now is the equivalent of this. Once you get here, it's just a 3x3 until, of course, we get to parity. But so the first thing you would do is your cross, just like on this one. So I start on white, so there's my white right here. You have your blue and white edge. It's just like a 3x3. And I'm not the best cross person, but let's just do a basic cross. So there's your cross, just like on a 3x3. Your centers are matching, and there is your cross. Let's just do a cross on this. Same thing. There is your cross. Okay, so next would be F2L, or in this case F3L, and you could do beginner's method, but I actually kind of forgot beginner's method because I've been doing CFOP for so long. So this would be my first pair. Red and green edge, red and green corner. Needs to go right here. Take it out. And there's my first F2L pair, or F3L you could call it. So next we have a red and blue edge right here. There's the red and blue corner. So if I had it right there, oops. There we go. There's my red and blue pair, which I would insert, let's say, a back sledge. So now we have these two done. We have this one, which can go right here. And then we have this one, which I would do like that. So now my F2L is done, just like I would do it on a 3x3. So like in this case, you know, simple F2L. That one, red and green. Where is red and green? And then here we have and then, so there's your F2L, just like on here. So now we have this bar. So just like on this, you would do F sexy F prime. F sexy F prime. And now you have, you know, your OLL case. In this case, it's a different case than this one. So I would just solve. It's hard to finger trick this, so I got to memorize exactly what it is. Like that. So that's my OLL. And then now we have PLL. Looking at this, it does look like we have PLL parity. I'm not sure. Hang on, there's my headlights. Let's see if I can. Let's just do your simple AA perm. No, we do not have parity, and so this is just now a U perm. Damn it. And there you go. And then so your cube solved. It's just like a 3x3 until you get to parity, which I'm about to go over right now. So here is PLL parity, where you have only two edges that need to be flipped, and these two are solved. Like, that's not, you can never have that on a 3x3. It's always 3 or 4, whether they need to swap like that, or these need to go like this or like this, but you can never have just two. So this would be PLL parity, and you could really hold it anywhere, but I guess I would just hold it like this. I guess I would just hold it like this, where these two are on the front and right. And then you would do PLL parity, which would be U wide 2, little r2, U2, little r2, U2, little r2, and then U wide 2. And what that does is it makes it a U perm. So now we only have one on the back, one solved, and then now 3 are unsolved. And then so this would be my UB. And then solved. And then so OLL again, let's try that. R wide U2 X, R wide U2, R wide U2, R wide prime U2, L wide U2, R wide prime U2, R wide U2, R wide prime U2, and then R wide. So in the 3x3, this would be like the equivalent of this, where you have two edges, or you would have two edges right here, but you can never have 1, 2, 3 edges without one. You just can't have that, not on a 3x3. So if you have it on this, where if you have an odd number of edges, 1 or 3, then you have parity. And then so you're going to switch this one, make sure it's in the front, not like this, and this one will switch these two to make 4. And then so that is again R wide U2 X, R wide U2, R wide U2, R wide prime U2, L wide U2, R wide prime U2, R wide U2, R wide prime U2, R wide prime. And then so that's how you would solve your OLL parity, and that's pretty much all you need to know to solve the cube. It's a 3x3 until you get to those parities, and then you solve parity, and then that's it. So the last time we had PLL parity, these two were on the sides right here, the front and the right, and then these two were solved. Well, now it's these two are solved, or these two are solved, and then it's opposite. Either way, if you have only two swapped, like two unsolved, whether it's right here or right here or right here or blah blah blah, then that's also parity, because you'll notice that this is not a PLL case. You're gonna look at it and say, the hell is that? I never seen that. That's PLL parity, and then you just do the PLL parity to make, well, in this case, it would solve it, but if it were like this, then it would put you in a U-perm, and you know, and then you just hold it, you would hold it, this one you would hold front and back, and there it is. I mean, that's pretty much, it's pretty much the 4x4. I hope you learned how to solve 4x4 from my tutorial.